Hey guys, we are going to start on our second half of our statistics unit, and this is going to finish out the school year for us. What I want you to do first is I actually want you to grab a penny or a nickel, a dime, a quarter, some coin of some kind, and I want you to flip it 20 times, okay? If you don't have a coin, you can get an app or go online, get like an online simulator, and flip a coin 20 times and record your results. So how many heads and how many tails did you get? So go ahead and pause and do that for me. All right, welcome back. I recorded what I got. You should have whatever you have. They're going to be different, and that's okay. That's the purpose of all this. So when I flipped my coin, 5 times I got the heads and 15 times I got tails. You should put what you got on there. Maybe you got better results than I did. So what was expected? If we're flipping a coin 20 times, we are expecting, right, to get 10 and 10. There's 2 sides to a coin, 20 flips, 20 divided by 2, we would expect 10 and 10, right? So now I want you to compare with what you got with what was expected, okay? Let me know, are they close? Explain. Mine personally are not close, okay? Because they are, let's see, I'm going to say far from expected value for me personally. So like if yours was closer, maybe you got like 12 and 8. You could say they were like kind of close because they were not too far away from the expected outcome, but they weren't perfect. So you just fill that in for yours personally, okay? Check with your neighbor, that's me. All right. So not everyone was going to be close, okay? Not everyone got 10 out of 10. I doubt very many people got exactly 10 out of 10, okay? Most people probably got further away, maybe 17 and 3, 15 and 5, something like that. Yeah, so probably further away from what was expected. So maybe 20 flips is not enough. So let's get a census of what it would be if I took the results of the entire class. Now, obviously, we can't do that right now, so I'm going to use some results from a previous class. Okay, that class had 26 students. Whoop. Okay, so if each student flipped the coin 20 times, we would expect to get 260 tails, and heads, and we would get 260 tails is what we would expect. Okay, this particular class, so out of the expected 260 for each, okay, they got 200, oh, what has happened with my pen today? Okay, they got 245 heads and 275 tails, okay? So why are we doing this? We are doing something called hypothesis testing, okay? We are going to begin hypothesis testing always assuming with something that we call the null hypothesis, okay? So what is that? Well, the null hypothesis, I should have made this blank bigger, states that there is no difference between. So we always assume that nothing's going to happen, okay? So think null and no. Null hypothesis states there's going to be no difference between the two groups being tested. For us, it's what actually happened versus what we were expecting to happen. Okay? Then we also always have an alternate hypothesis. There you go. And this shows that this would be the opposite. So I would say that there is a difference. So null, no difference. Alternate is opposite, that there is going to be a difference. Okay? So with our coin flipping, the two groups would be our expected outcomes, right? Hold on, it's having a moment. There we go. Our expected outcomes and the observed outcomes. Okay. So for this, our null is going to state that there is no difference between the two. Okay. So for our null hypothesis, for the hypothesis test, state the null hypothesis. So if we're saying there's no difference, we're going to say that there's going to be an equal chance there we go, of heads versus tails. Okay, so there's not going to be a difference between the two. Alternate means opposite. So we're going to say the opposite of what we just said. We're going to say there's not an equal chance. Not equal chance of getting heads and tails. Okay, so null hypothesis, no difference. Alternate, opposite, there is going to be a difference between the two. Okay, so we always have to assume that our null hypothesis is true unless we have enough evidence to reject it. Okay, so in this case of my coin flips, what do we have to assume? Well, we have to assume that there's an equal chance, right? Equal chance of my heads and tails. Okay, so we did gather some evidence to determine if we should reject it or not. Okay, so what evidence did we collect? Well, I got evidence from 26 people. Well, 27 really if you include, well, no, and myself, right? Here, we'll use the class, okay? So we use 26 people. So 26 people flipped a coin. 20 times. So we had 520 total flips. Okay, that is the evidence that we gathered. All right, so now let's analyze our evidence. Okay, so we're going to look before we can make a decision. So let's make graphs to help us with our decision. In this case, we're going to find what percent of outcomes were heads and tails. So out of my 26, or my 520 flips, so for my heads, out of the 520, we had, what, 425? Okay, that's going to result in 47% of heads, and my tails resulted in 275 out of my 520, and that's going to result in 53% were tails. Okay, well, what was expected to happen? Well, we were expecting half and half, right? We were expecting 50% and 50%. Equal chance, no difference, right? Are these basically the same? Well, they're pretty close, right? Are they radically different? No, they are not. Okay, so if I have to choose between basically the same versus radically different, I would say these are basically the same. Okay. Okay, we are also going to make a little bar graph here. So my percentages, I'm going to do 25, 50, 75, and 100. On the side for percentages, 50. There we go. All right, so what did we observe? We observed 47% of heads, right? And this is our heads. And then we observed 53%, so a little bit above, right, of our tails. And what did we expect? We expected right at 50 for my heads, and we expected right at 50 for the tails. So we can compare percentages, we can compare some histograms, a side-by-side bar graph. All right, so if our data, our evidence is basically, if they are basically the same, that was right, if they are basically the same, then we do not reject the null hypothesis. Again, should have made that blank longer. Okay, so if they're basically the same, we are not going to reject the null hypothesis, okay? Because we don't have enough evidence to do so. Okay, so in other words, we're going to assume that randomly selected coins have 50-50 chance of landing on heads and tails. Okay, if they are radically different, okay, if there is a huge obvious difference between the two, okay, then we are going to reject the null hypothesis because you have the evidence to do so. So you have proven that there is a difference. Okay, so you have to have evidence to prove there's a difference. So there is enough evidence to say that the coins are not 50-50. Okay, so based on our data, what should we say? Well, I would definitely conclude that based on my data, that they are basically the same. So we are not going to reject the null hypothesis. We're going to keep it, which stated that there was no difference between the two groups. Okay, that's what today is all about. All right, so significance of experimental results. So what the steps that we have to do, we have to come up with the question, write down the appropriate hypothesis, okay? So we always say null is no effect, and the alternate is that there is going to be an effect, okay? Step 2, we always collect our data for evidence. Step 3, we have to analyze it by transforming it into summary statistics and graphs. We're going to use box and whiskers today also. And then after you have comparative data, then we can decide whether or not to reject the null hypothesis or not based on our evidence. So do we have enough evidence to show that there is a difference? If there is, we can reject the null because we've proven there is a difference. Okay, so we always assume no difference unless we can prove otherwise. All right. In a class experiment, 2 classes are given an article to read. The control group reads the article in silence while the test group reads the article with music playing in the background. After reading, the students are quizzed on how much they remember. The teacher predicts the quiz scores will drop for the test group. The group scores are shown below. All right. So again, let me move this out of my way. The control group was silent, right? Oh, that's not going to help. Doop. The control group was silent. The test group had music. Okay, and he shows us the results. So remember, the null hypothesis is going to say that there's no difference. So what is the null hypothesis for this experiment? Well, we're going to say, and be specific as what it's referring to, we're going to say music is going to have no effect on the quiz scores. They will perform the same. So no effect. What is he testing? He's testing music. Null means no difference. So the music will have no effect, will make no difference on the quiz scores. We're going to predict that they are given the same. Okay? Now we have our data. It was given to us, right? That was step 2. Step 3, we have to analyze our data. So let's go over here. We are going to use box and whisker plots for these. So make sure you have your graphing calculator and you're ready to find out our data. I will help you with this first one. So I went back to, you should have it on your paper. If you need to, pause this. You need to put these values into list 1 to get your 5-number summary. So go ahead and pause and do that. All right, our 5-number summary for, remember this was the control group. This is no music. I'm going to say silent. Okay, this was a silent group. Our minimum was 72. Our Q1 is 76.5. Our median was 79.5. Q3 is 83.5. and our maximum was 95. All right. I'm going to go ahead and put that on here. So we have 72 is about right here. 76, 79, that's really close. 83, and then 95. Okay. So these are the quiz scores for there was no music. So this was when it was silent in the room. All right. Now let's get our data for the group that did it with music playing in the back. So go ahead and pause. We are now going, here we go. Clear out your list 1 and now put these values into list 1. Go ahead and do that and come back. Pause the video. You should have gotten a minimum quiz grade of 18, a Q1 of 47, a median of 55, a Q3 of 65.5, and a maximum quiz score of 77. All right, so now we're going to put these on the same number line. So here we go. We have 18, 47 is going to be about right here. 79.5, 83, oh, that was the wrong data. 55, there we go, median. Q3 is 65.5. There we go. And then our maximum was about 77. There we go. All right, and this had music playing while they took their quiz. Okay, so now let's compare. We can look at our 5-number summaries. We can look at our visual, which is the box and whisker. Okay, are the statistics the same or different? They are very different. Okay, how about, look at the numbers, 72, 18. Like each of these values, they are drastically different from each other. Okay, part B, are the box plots the same or different? They are very different. Look at the green and the blue. They are very different from each other. They do not share anything. So, do we have evidence to prove that there was a difference? Yes, we have evidence. So, yes, we are going to reject. Okay? We're going to reject the null. Remember, the null said there was no difference. We have evidence to prove that there is. Okay? So, yes, we have evidence. Reject the null. We have proven that music will affect their quiz scores. All right? Let's do another one. Here we go. A researcher is testing whether a certain medication for raising glucose levels is more effective at higher doses. In a random trial, fasting glucose levels of 5 patients being treated at normal dose, which is group A, and then 5 patients are being treated at a high dose. Okay, so this is normal. This is the normal group. This is the high dose group. And then their glucose levels were recorded below. So let's say our null and our alternate hypothesis. Remember, null means no and be specific. What are they researching? What are they comparing? Right? They're comparing the glucose levels. So my null hypothesis is going to be that my glucose levels will be the same no matter what dose is received. There will be no difference in glucose levels. Alternate means opposite. So my alternate hypothesis, we're going to say that the dose of medicine is going to result in different levels of glucose. All right, so remember, null means no. Alternate means yes. We have to assume the null is true unless we have evidence to prove otherwise. So let's go ahead and get our summary. So you can pause the video. Get your 5-number summary for group A and then go back and do it for group B. So pause and come back and compare with me. All right, compare your data with mine. So remember, our group B had the high dosage of the medicine, and then our group A had the normal. Okay. So now let's compare our evidence. Okay, So the box plots and 5-member summaries are, would you say they're about the same, or are they different? Well, let's look at them. Look at my numbers, super close together. Look at my box and whisker, they're like right on top of each other. Are they a little different? Yes. Are they radically different? No. Okay, so these are about the same. So that means that there is not enough evidence. I'm going to get the highlighter. This is being weird. Okay. Here we go. They are about the same. So that means that there is not enough evidence, okay, of different glucose levels for those taking normal dose and those taking a high dose of medication. So, because we don't have the evidence, we cannot reject the null hypothesis. So we must keep it. Okay, it's not too bad. None of this is brand new. The only kind of new part is the analyzing of it and making a decision on whether or not we have evidence to prove that there is or is not a difference. All right, so now it's time for you to try one. So you're going to try this one. Pause the video, see if, let's see, what are they comparing? Oh, if her morning class is better than her afternoon class. Okay, so pause the video, write down your null and alternate hypothesis, and come back to check those first. All right, pause. Here we go. You should have something that says that the morning and afternoon classes will have the same scores, right? There's not going to be a difference. The alternate is going to be that the time of day is going to result in different scores for the classes. Okay, so null means no difference. Alternate means there is a difference. And yes, you have to make it specific to the example. You can't just say no difference and difference. It doesn't work like that. All right, so now let's do our 5-member summaries and our box and whisker plots. So pause the video, get that written down, and then come back and check with me. All right, so compare with what you have with what I have. Make sure it's correct. And now we're going to analyze it. So looking at my 5-member summary, I notice every statistic for my afternoon class is less than every piece from my morning class. All 5 pieces of data are smaller. I also look at my box and whisker plot. I can clearly see that the red box and whisker, every piece of it is below the blue one. Okay? This is different from the one before. Here, there was some overlap, right? This one was lower, then this one was lower, then that one, and it kind of like bounced back and forth. It wasn't all generally below or all above, okay? Here, I can look at this information and go, oh, clearly the morning class did better and the afternoon class did worse, okay? I have evidence to suggest this because of all the data being below, okay? So, in conclusion, these summary statistics are very different for groups A and B. The box plots are significantly different for groups A and B. So we do have the evidence to reject the null hypothesis since there is a difference between the morning and afternoon classes. All right, so that is today's lesson. You are going to go ahead and work on the worksheet now with your null and alternate hypothesis and comparing data. And the next time I see you, we'll move on to the next lesson. All right, stay strong. The end is almost here, guys. We got this. Let me know if you have any questions.